Hello class, this is Mr. Baruch, and this is going to be our flipped classroom on particle diagrams. So this is going to be a representation of how you would draw or how you would recognize drawings of atoms, molecules, elements, and compounds as particle diagrams. So first, please pay attention to the top two lines that say let the dark circle represent any single atom, and this open white circle represent any different atom. So I have two boxes here that I'm showing a bunch of atoms together. The first box represents an element. Now, how do I recognize that this is an element? Well, I see multiple of the same atom. I have 4 atoms in this box, so this represents a bunch of the same atoms in the same container. This is what we'd call an element. This could be the element carbon. This could be the element helium. This could be any element. The only thing I would point out is, since the atoms are so far apart from each other, this is most likely representing a gas. So this could be helium gas or neon gas or something like that. To the right, I have another picture, also apparently in the gas phase, because again, they are so far apart from each other. The difference this time is that 2 of the atoms are combined, which means that each individual one, let's say this right here, represents a molecule. So I have a bunch of molecules, but these molecules are diatomic. And if you remember, diatomic means 2 of the same atom. So this could be O2 gas, or H2 gas, or N2 gas, one of the diatomic elements. Again, it's a gas because they're so spread out, but it is still an element because it still represents only the same type of atom. Now below, I have an example of a compound and a mixture of compounds. I can tell that this is a compound because now I have 2 different atoms combined. Once again, each one of these represents a molecule. But since I have a bunch of them in the same container, this is a compound. This could be, I don't know, carbon monoxide. This could be some other molecule that has 2 different atoms in it. Over here, I now have a mixture of compounds. Now, how do I know it's a mixture? Because this molecule right here and this molecule right here are not the same. This one has 1 black circle and 1 white circle. This one has 1 black circle and 2 white circles. So maybe this is carbon monoxide and maybe this is carbon dioxide, CO and CO2. But in any case, there are 2 different molecules that are represented in this box. Again, they're spread out, so they're probably gases. This is a mixture of compounds. Now, what I could also do is, if I wanted, I could show a mixture of atoms. I can have 1 dark circle, 1 light circle, another dark, another light, another dark, and now I have a mixture of atoms. And if I would combine this box and this box, I would have a mixture of atoms and a mixture of molecules. Therefore, I'd have elements and compounds. So these represent elements, these represent compounds, and I can mix them all together and have a mixture of elements and compounds, or atoms and molecules. Next, I want to show the same atom, but in 3 different states. First, solid. Now, how do I recognize that these atoms are in the solid phase? Well, notice that they're all packed together very tightly in some geometric pattern. They're all kind of touching each other. That's what a solid would look like, a regular geometric pattern very tightly held together. This could be any atom. This is the same picture, but notice now the atoms are separated by a little bit. They're still at the bottom, because after all, liquids don't float to the top, but they are still kind of close, but not really in some geometric pattern. Where this one shows the same atoms again, but now they're all spread out everywhere. So this is a gas. So again, we have solid, liquid, and gas. Here we have compounds, mixture of compounds. Here we have an element and a diatomic element. So these are what we call particle diagrams. You may be required to recognize a particle diagram and tell what's in that picture. Is it a solid? Is it a liquid? Is it a gas? Is it a single element? Is it a compound? Is it a mixture? Or you may be required to draw an example of something like that. So let me show you an example where you would have to draw. So let's say once again that we have two different symbols. We have this symbol right here. Let's say this symbol is going to represent a single atom of oxygen. And then we have this symbol right here. Let's say that this is going to represent a single atom of hydrogen. And then they give you a box. They say, in the box, show a molecule of water. All right, so water is H2O, which means I need two dark circles and one light circle. So I will draw two dark circles and one light circle. Now, it doesn't matter how you put them together. You could put the two dark circles together and then the light circle on the other end. But I'm just showing you that they are connected. This is how you show a molecule. They must be connected. They must be touching. Okay? Now, what if they say, all right, now that you've drawn a molecule, what about showing a picture where it's a compound, showing more than one? And a minimum of, let's say, 4 molecules, but they want it in a specific phase. Let's say gas phase. Well, in gas phase, I would have to make sure they are very far apart. So I draw one there, one's already there, there's another one at the top there, maybe another one here. So that would be a compound of water in the gas phase. Remember, the letter G stands for gas. Again, I could have drawn it as a solid if I put them really, really close together, or a liquid a little spread apart. But that's how you would draw a picture of water in the gas phase if they gave you those symbols. Thank you very much, and as always, if you want, please rewatch the video and take some notes.